Okay, on number 5, you're using coordinate geometry to determine if the quadrilateral that has these 4 vertices is a parallelogram or not. So remember, you only have 6 reasons to pick from. One of these 6 things must be true if you have a parallelogram. These are the 5 properties, and this 6th one is an additional test to see if you have a parallelogram. There's only 3 of these, however, that you can use doing coordinate geometry, and that's the opposite sides being parallel, which uses the slope formula, the opposite sides being congruent, which uses distance, or the diagonals bisecting each other, which uses the midpoint formula. So you're only going to focus on these 3 reasons. Those are the only 3 possible reasons for why you have a parallelogram if you say yes. So the first thing you can do is graph these points. A is at -1, 3. B is at 2, -1. C is at 8, 1. And D is at 5, 5. So when you can, whoops, I put that at 8, 5, 4, so ignore that point. So when you connect these points, you can tell, Curtis, go away. You can tell that it does look parallelogram-ish, if that's a word, but you remember you cannot go by looks, you have to go by the math to determine if it is one. So I'm going to show you all 3 ways, and you can pick whichever is your favorite. Probably number 2, using the distance formula, should be your last choice, unless you're just really fantastic at the distance formula. It has the most possibility for error on it. So if you're looking at the slope formula, you're going to be looking at the slopes of the opposite sides, and you want them to be equal in slope, which means that sides are parallel if the slopes are equal. So I'm going to start off finding the slope of AD and BC because those are opposite sides. I can tell the slope is positive because those lines are going uphill. I can look at the rise of a run. To go from A to D, I go up 2 and over 1, 2, 3, 4, 5, 6. So the rise was 2 and the run was 6, which simplifies to 1/3 for my slope. For B to C, I rise 2, 1, 2, run 1, 2, 3, 4, 5, 6. So again, my rise is 2, my run is 6, which also simplifies to 1/3. So since AD and BC have equal slopes, we know that those sides are parallel. But remember, one pair of opposite sides being parallel is not enough to show it's a parallelogram. Both pairs of opposite sides must be parallel. So I'm also going to find the slope of the other opposite sides, AB and DC. So with AB and DC, I can see they're both going downhill, so I know the slopes are going to be negative. To go from A to B, I go down 1, 2, 3, 4, and to the right 1, 2, 3. So down 4, right 3 means my slope is -4/3. With D to C, I go down 1, 2, 3, 4, 1, 2, 3, so the slope is also -4/3. So since those opposite sides have equal slopes, we know that those sides are also parallel to each other. So this would be one reason that we can say for sure that it is a parallelogram. If you use the slopes, then you need to say that the reason why is since you have opposite sides giving you equal slopes, you know the opposite sides are parallel. So that would be your reasoning if you use slope. Remember, if you use slope, don't tell me the opposite sides are congruent. Slope doesn't tell me that you have congruent sides. You can have 2 sides that are parallel and them not be congruent. So slope tells us if they're parallel or not. If you want to use the reason that opposite sides are congruent, then you must find the lengths of those sides, which means you're using the distance formula or you are using Pythagorean theorem. So if you want to use the distance formula from A to D, it's probably easier if you go back and look at your coordinates here. So we're going to do the x sub 2 minus my x sub 1 would be 5 minus -1, which is the same thing as 5 plus 1 squared, plus the difference in my y's, 5 minus 3 squared. So 5 plus 1 is 6, so that would be 6 squared, plus 5 minus 3 is 2, 2 squared. So 6 squared is 36, 2 squared is 4, So that gives me the square root of 40, which we always want to be in the habit of simplifying our radicals. So 40 can be split into 4 times 10. 4 is a perfect square. When we take the square root of it, it comes out as a 2. So that would be 2 root 10 for the length of AD. So we want to try the opposite side and see if it also gets that same length. So we're going to find the distance of BC. Remember, I'm not using segment bars because I'm finding a measure. So I'm going to use the coordinates again for B and C. So second x minus first x would be 8 minus 2 squared, plus y minus y would be 1 minus a negative 1, or 1 plus 1 squared. So again, 8 minus 2 is 6, so that's 6 squared again. 1 plus 1 is 2, so that's 2 squared again. So of course we know we're going to end up with the square root of 40, which simplifies to 2 root 10. So we know these opposite sides are congruent. So I can use those as congruent sides, but that's not enough to say it's a parallelogram, because that's just one pair of opposite sides that is congruent. You could, however, if you wanted to, use the slopes of AD and BC and the distance of AD and BC to use reason number 6 if you would like. You could say one pair of opposite sides is both parallel and congruent, showing they have the same slope and the same length. So if you didn't want to use these slopes, but the slopes here and the distance here, that would be another reason you could use for that being a parallelogram. If I'm going to use opposite sides are congruent, though, I have to find the other 2 lengths as well. So I'm going to find AB and DC and see if they're the same length. So again, using the coordinates of A and B, we would do 2 minus a negative 1, which is 2 plus 1 squared, plus negative 1 minus 3 squared. So we have 2 plus 1 giving me 3 squared. Negative 1 minus 3 is negative 4 squared. Very important, those parentheses, to remind us that's negative 4 times negative 4. So when we square numbers, we always get a positive answer. 3 squared is 9. Negative 4 squared is negative 4 times negative 4, which is positive 16. When we add those, we get 25. 25 is a perfect square. The square root of 25 is simply 5. So our answer doesn't contain a radical. So when we find DC, we're going to be doing 5 minus 8 squared plus 5 minus 1 squared, and do the math inside the parentheses. 5 minus 8 is negative 3 squared, plus 5 minus 1 is 4 squared. Again, a negative squared is positive. Negative 3 times negative 3 is positive 9. 4 squared is 16. Those add to get 25, which is also 5. So we also proved that these 2 sides are congruent. So now, since both pairs of opposite sides have the same length, we could also use the reason that opposite sides are congruent. You do not have to do all of these. If you do slope, give this reason. If you use distance, give this reason. Just make sure that your reason matches the work. So if I want to do diagonals bisecting each other, I'm going to be using the midpoint formula. And I'm doing that for the diagonals, not the sides. So my diagonals are connecting the 2 non-consecutive vertices of A and C and B and D. So these are the segments I'm finding the midpoint for. So if I want to find the midpoint, I'll get me some new real estate over here, of segment AC, remember the midpoint is simply averaging your x coordinates and averaging your y coordinates. So for A and C, the x's are negative 1 and 8. I'm going to add those together and divide by 2. The y's are 1 and 3. I'm going to add them together and divide by 2. So my midpoint should be at negative 1 plus 8 is 7. 7 divided by 2 is either 3.5 or 7 halves. And then 1 plus 3 is 4. 4 divided by 2 is, 2. Let's pretend that parentheses goes that way. So 3.52 is the midpoint from A to C. Now we want to find the midpoint of B to D, and if it's the same, then we know this is a parallelogram. So using B and D, we have the x's are 2 and 5, so we'd have 2 plus 5 divided by 2. The y's are -1 and 5, so -1 plus 5 divided by 2. So 2 plus 5 is 7. 7 divided by 2 is 7/2 or 3.5. -1 plus 5 is 4. 4 divided by 2 is 2. They have the same midpoint. That point right there is the midpoint of both diagonals. So if I use midpoint, the reason for why it's a parallelogram would be that the diagonals bisect each other since they have the same midpoint. So again, you won't use all three reasons. You would just use the reason that matches your work. If you use slope, say the opposite sides are parallel. If you use distance, opposite sides are congruent. If you use midpoint, diagonals bisect each other.